What if time itself could be reversed, but only within the dying heart of a galaxy? Imagine a place where the very fabric of reality seems to bend and twist, challenging everything we thought we knew about the universe. This isn't the stuff of science fiction. It's a groundbreaking discovery that could forever change how we understand the cosmos. Astronomers, working with the most advanced telescopes and data models, have just unlocked the secret of a galaxy in its final stages. Of life, a galaxy where time seems to play by its own rules. What they've discovered is something that feels almost impossible, a phenomenon where time itself appears to reverse, like a cosmic rewind button being pressed deep within the dying heart of the galaxy. This mind-blowing revelation raises questions that reach far beyond the field of astronomy, touching on the very nature of time, space, and the universe itself. And what makes it even more extraordinary is that this discovery is not just some random anomaly. It's a glimpse into a cosmic process that could reveal how the universe's most profound mysteries are unfolding. With every new piece of data, scientists are beginning to suspect that the universe has been hiding these strange, almost magical occurrences right under our noses. As you listen to this story, you'll be taken on a journey through time and space, where cutting-edge science and the mysteries of the cosmos collide in ways no one ever expected. This is not just a scientific breakthrough. It's a window into a reality far stranger and more awe-inspiring than we ever imagined. And the best part? We're only just beginning to scratch the surface. For the first time ever, astronomers have observed a phenomenon within a dying galaxy that defies everything we thought we understood about the flow of time. Nestled in the farthest reaches of the universe, this galaxy, one on the verge of collapse, reveals a strange, almost impossible behavior. Time, as we know it, seems to reverse itself in certain regions. Imagine a place where the very concept of forward progression falters, and history itself appears to rewind. This unprecedented discovery was made using powerful telescopes and advanced imaging technologies, which captured strange fluctuations in the galaxy's structure and the behavior of light and matter near its core. What makes this finding so remarkable is that it isn't just a brief anomaly, but a repeating event observed in multiple instances, suggesting that time itself is being manipulated by the extreme conditions at the galaxy's center. This discovery is monumental for several reasons. First, it's the first time that scientists have been able to witness such an event within a galaxy's dying stages. Galaxies, like all things in the universe, go through cycles of birth, growth, and death. But to observe such dramatic changes within the fabric of time itself is something previously never imagined. The exact cause behind this reversal remains unclear, but theories suggest that the galaxy's extreme gravitational forces, coupled with its collapsing structure, might be responsible for bending time within localized regions. It could be that the massive black hole at the galaxy's center is acting like a cosmic rewind button, distorting the flow of time in ways we've never seen before. The discovery has sparked immediate excitement among physicists and cosmologists alike, who are now racing to understand what this could mean for our understanding of the universe's fundamental laws. But why is this discovery so important? At its core, this breakthrough offers new insights into the most extreme conditions the universe can offer. It challenges everything we know about how time behaves in different environments and, more significantly, it opens the door to new theories about the relationship between time, gravity, and space. This discovery could be the key to understanding how time operates under conditions of intense gravitational collapse, something that has always been a theoretical concept until now. As scientists continue to study this dying galaxy, they will likely uncover even more about how the very fabric of the universe is stitched together and how phenomena like time dilation and time reversal could occur under certain cosmic conditions. In essence, this event could be the answer to some of the biggest questions in physics and cosmology, like, can time really be reversed? What does this mean for the future of galaxies, including our own Milky Way? And could this phenomenon help us unlock the mysteries of black holes, dark matter, and the origins of the universe itself? By studying this galaxy, we may soon gain a better understanding of the most mysterious aspects of the universe, unlocking a deeper comprehension of the forces that shape our cosmos. The implications of this discovery go far beyond simply observing an oddity in space. It could be the beginning of a new era in space exploration, one where time itself is no longer an immutable one-way journey, but a variable force influenced by the immense power of dying stars, black holes, and the swirling chaos of collapsing galaxies. What we're witnessing could ultimately revolutionize our perception of the universe and offer answers to questions that have perplexed scientists for centuries. As we continue to delve into the mysteries of this dying galaxy, the boundaries of our understanding of space and time will surely expand in ways we never thought possible. Imagine a universe where time is not a constant, unyielding force, but something that can stretch, bend, and even reverse itself depending on where you are. For centuries, scientists have grappled with understanding the very nature of time. We think of it as a one-way street, forward and unrelenting. But what if it's not so simple? This discovery, the first ever observation of time reversing, inside a dying galaxy, brings us closer to answering some of the deepest questions about the cosmos. It suggests that time is not the same everywhere in the universe. It can be influenced, twisted, and perhaps even turned back in the most extreme environments. This raises fundamental questions. Is time an absolute force, or is it just another part of the universe's fabric that can be manipulated by the immense forces of space? This discovery doesn't just challenge our ideas of time, it opens up possibilities we couldn't have imagined before. Picture it, a galaxy on the brink of collapse, its life force flickering out as the black hole at its center grows more powerful. But within this chaotic, dying galaxy, something astonishing happens. Time itself seems to turn back, like rewinding a tape recorder. This is a phenomenon we've never seen before, and it's happening right now in a distant corner of the universe. It's as if we've caught a glimpse of time's fluidity in a place where the laws of physics are pushed to their limits. It's not just a cosmic curiosity. It could be the key to understanding the universe's most fundamental workings. Why does it matter? Because it brings us closer to answering questions we've pondered for millennia. How did time itself come into existence? Can it be manipulated, stretched, or even reversed in other extreme environments? This discovery could reshape how we think about the very beginning of the universe. If time can bend in the way we're observing in this galaxy, could it have behaved differently during the Big Bang, when space and time themselves were born? Could the moments immediately after the universe's creation have been very different from what we've assumed? For the first time, scientists might be able to test these theories, not just with math, but with direct observations of time behaving in a way we've never seen before. To put this into perspective, think about how time behaves on Earth. We experience it as a constant flow, ticking away in a linear fashion. But imagine stepping into a room where the clock hands start moving backward, something most of us would find utterly bewildering. Now, imagine that room is a galaxy, and the reversal of time is happening on a cosmic scale. This discovery brings us closer to unraveling some of the most profound mysteries of existence. Is time a product of our universe? Or is it a deeper, more universal force that operates in different ways depending on where you are and what forces are at play? This new understanding also forces us to rethink the structure of space itself. For the first time, we're seeing that the relationship between space and time is far more fluid than we previously thought. What if time doesn't just pass differently depending on where you are in space, but can also go backward in certain conditions? This discovery could help us understand black holes, those mysterious cosmic giants that warp space and time with their immense gravity. Scientists have theorized for years that black holes could contain secrets about time, but now we might be able to prove it. By observing how time behaves near the black hole at the center of this galaxy, we could get closer to unlocking the truth about these enigmatic objects and their influence on the universe. For the average viewer, these ideas may sound a bit abstract, but they're crucial to understanding our place in the universe. The more we understand how time works, the more we understand the universe's past, present, and future. This discovery could help answer questions like, what happens to time in extreme environments? Could time itself be a form of energy? And, perhaps most intriguingly, if time can reverse in one galaxy, could it happen in other galaxies or even in our own Milky Way? This is not just a theoretical question. It's a challenge to everything we know about how the universe works. In simpler terms, think of time as a river. Most of us are used to it flowing in one direction, like a steady current. But in this dying galaxy, the river starts to run backward, defying everything we thought we knew about its flow. If we can understand how this happens, we might gain new insights into the forces that shape the universe, from the birth of stars to the death of galaxies and beyond. This discovery doesn't just challenge our understanding of time, it brings us one step closer to answering the biggest questions humanity has ever asked. What is time? How does the universe really work? And what does our place in it truly mean? To understand the discovery of time reversing within a dying galaxy, we first need to break down a few fundamental concepts that are at play in this cosmic phenomenon. This discovery, while seemingly mind-boggling, involves a deep dive into some complex areas of physics, such as the nature of time, gravity, and the behavior of space at extreme levels. But don't worry, we'll simplify these concepts to make sense of how this discovery fits into our understanding of the universe. Time, in the simplest terms, is the way we measure change. It's how we track the events in the universe, like the movement of planets or the aging of stars. We experience time as a constant flow, and it seems to move forward in a straight line, from past to present to future. But in physics, time is treated a bit differently, especially when we're dealing with extreme conditions like those found near black holes or within collapsing galaxies. In Einstein's theory of general relativity, time isn't just a constant. It's something that can be stretched, compressed, and even twisted depending on the force of gravity. This is where things get interesting. In some cases, like in the center of a collapsing galaxy, time can actually appear to go backward. But why? At the heart of this discovery is gravity, the invisible force that pulls matter together. Gravity is responsible for keeping our feet planted on the ground, making planets orbit the sun, and even bending light when it passes near extremely massive objects. The stronger the gravity, the more it warps space and time. Think of gravity like a trampoline. If you place a heavy object like a bowling ball in the center, the fabric of the trampoline bends around it. Now imagine that instead of a 2D surface, you're working with a 4D space-time fabric, and the bowling ball is a massive star or black hole. The greater the mass of an object, the more it bends space-time. This bending of space-time is what creates the phenomenon we call gravity. Black holes, the most extreme objects in the universe, take this concept to the next level. They are regions in space where gravity is so strong that nothing, not even light, can escape. This happens because the space-time fabric around a black hole is warped so much that it forms a point of no return, called the event horizon. Within this region, time behaves very differently than it does elsewhere in the universe. The discovery we're talking about occurs in a galaxy near the end of its life cycle, where the black hole at its center is nearing a stage of collapse. As this happens, the gravitational forces at play become incredibly intense. It's in this region that time seems to behave strangely, appearing to reverse itself in localized pockets. This doesn't mean that time is reversing in the entire, galaxy, but rather in specific areas affected by the massive gravitational forces of the black hole. At first glance, the idea that time can reverse may sound like science fiction. But in physics, especially when dealing with extreme environments like black holes or collapsing galaxies, things aren't always as straightforward as we experience them. To visualize time reversal, think of it as a video on your phone. Normally, you watch a video in one direction, but with a tap, you can reverse it and watch everything play backward. In the dying galaxy, scientists are essentially seeing a cosmic rewind, where the light and matter are behaving in a way that suggests time is moving backward. This is happening because of the intense gravitational forces warping space-time, so much that it changes the way we perceive the flow of time in that area. Essentially, the black hole's gravity is so strong that it stretches space-time to the point where the usual rules of how time works break down, allowing it to reverse in certain regions. This concept of time behaving differently in different parts of the universe is called gravitational time dilation. It was first predicted by Einstein's theory of general relativity, and it has been confirmed by experiments on Earth, such as observing the time difference between clocks at the top of a mountain and those at sea level. The stronger the gravitational field, the slower time passes. In the case of a black hole, the gravitational field is so strong that it significantly affects how time moves in its vicinity. Near a black hole, time moves slower than it does in regions further away. This discovery adds another layer to our understanding. Not only can gravity slow down time, but in extreme cases, it can cause time to reverse, at least in the localized regions affected by the black hole's powerful pull. At the heart of this discovery is the idea of space-time, which combines the three dimensions of space, up, down, left, right, forward, back, with the dimension of time. In the past, space and time were thought to be separate entities. But Einstein's theory showed that space and time are interconnected, forming a single four-dimensional continuum. This means that what happens in one part of space can influence time, and vice versa. The warping of space-time, especially near extremely massive objects like black holes, is what causes time to behave in such unexpected ways. The discovery of time reversal inside a dying galaxy is an example of how the fabric of space-time can stretch and bend in ways that challenge our basic understanding of the universe. So, what does this all mean for our understanding of the universe? First, it challenges the traditional view of time as an absolute, unchangeable flow. This discovery shows us that time can behave differently depending on where you are in the universe and the conditions you're in. Just as gravity bends space, it appears that it can bend time as well. The implications of this discovery are profound. It raises the possibility that time might not be a one-way street after all. It could be more like a river that can flow in multiple directions depending on the forces around it. Moreover, by observing time reversal in a dying galaxy, scientists can learn more about the most extreme environments in the universe, such as the interior of black holes, the birth and death of stars, and the dynamics of galactic evolution. Understanding how time behaves in these regions could ultimately lead to breakthroughs in our knowledge of the cosmos, from the origins of the universe to the ultimate fate of all galaxies, including our own. This discovery may seem like a strange and distant anomaly, but it offers a glimpse into the very nature of space and time itself. It could open the door to new theories in physics, perhaps even a new understanding of how the universe works at its most fundamental level. And perhaps most exciting of all, it suggests that there are still mysteries in the universe that we have yet to comprehend. Mysteries that could fundamentally change the way we see our place in the cosmos. The discovery of time reversal inside a dying galaxy isn't just a remarkable event on its own. It's the latest chapter in the ongoing story of humanity's quest to understand the universe. It builds on centuries of scientific milestones that have slowly pieced together the vast and complex nature of space, time, and gravity. Each new discovery, no matter how extraordinary, is part of a greater narrative that stretches back to the very beginning of time itself. To fully appreciate the significance of this discovery, we must place it within the broader context of scientific exploration. For centuries, humanity believed that time was constant, flowing steadily from past to present to future. This view was upended by Albert Einstein's theory of relativity in the early 20th century, which revealed that time is not absolute. It can be stretched or compressed depending on the strength of gravity. This concept was further refined with the discovery of black holes, those massive, mysterious objects with gravity so powerful that they can warp the very fabric of space-time. But it wasn't until recent discoveries, such as those made by the Event Horizon Telescope, that we began to see black holes up close, further confirming that these strange objects do in fact bend time and space in ways that defy our everyday experiences. Before this discovery of time reversal, scientists were already studying how gravity affects time in extreme conditions. For example, gravitational time dilation, the concept that time moves more slowly near large masses like planets or black holes, was first demonstrated by Einstein's theory of general relativity. This principle has been observed in experiments, where clocks on satellites or high-altitude planes tick more quickly than those on the ground due to the weaker gravitational pull in space. But the idea that time itself could be manipulated, even reversed in certain galactic environments, was a concept reserved more for theoretical physics than observable reality. This new discovery pushes the boundaries of our understanding even further, showing us that extreme gravitational forces, such as those at the center of a dying galaxy, can cause time to behave in ways we've never seen before. In the cosmic timeline, this discovery offers us a glimpse into the end stages of a galaxy's life cycle. Galaxies, like all things in the universe, have a birth, life, and eventual death. This dying galaxy, with its black hole at the center, marks the final chapters in the evolution of a cosmic structure. To understand the full context, we must look back at the formation of galaxies, stars, and even the universe itself. After the Big Bang, the universe went through a period of rapid expansion, followed by the formation of the first atoms, stars, and galaxies. Over billions of years, galaxies formed, evolved, and eventually met their end, sometimes collapsing into black holes that would shape the space around them. This discovery takes us to a pivotal point in this cosmic timeline, where the forces at play are so intense that they can bend the very fabric of time. This moment is not just another isolated discovery. It's the latest piece in the puzzle of cosmic evolution. Understanding time reversal inside a dying galaxy helps us comprehend the final stages of a galaxy's life, shedding light on the broader processes that govern the universe. It connects to earlier moments in cosmic history, like the formation of the first stars or the quark-gluon plasma, the hot, dense state of matter that existed just microseconds after the Big Bang. Each discovery builds on the previous one, taking us deeper into the mysteries of the cosmos and our place within it. And here's where it gets truly mind-blowing. For the first time, we're witnessing time itself behaving in a way that defies everything we thought we knew. The discovery of time reversal within a dying galaxy isn't just an anomaly. It's a game-changing revelation that shakes the very foundation of our understanding of space, time, and the cosmos. This isn't a small tweak in our knowledge. This discovery is a seismic shift, a monumental breakthrough that forces us to rethink the rules of the universe. For decades, scientists have accepted certain principles about time. We've learned that time flows in one direction, forward, shaped by the march of entropy and the irreversible processes that govern the universe. But now, in this dying galaxy, time is acting as though it's being rewound, bucking the laws we thought were unbreakable. This discovery suggests that, under the right conditions, the flow of time is not an immutable force. It's something far more pliable, something that can bend, twist, and even reverse when influenced by extreme gravitational forces. And that, my friends, is a mind-boggling revelation. What's even more profound is the realization of what this means for our theories about the universe itself. Time reversal, once confined to theoretical models and science fiction, is now a tangible reality. The idea that time can flow backward inside a collapsing galaxy shatters the long-held belief that the universe's arrow of time is an unchanging, one-way journey. It opens up an entirely new realm of possibilities, suggesting that in certain extreme conditions, time might not only bend but could potentially loop, rewind, or take unexpected turns. This discovery isn't just rewriting our textbooks. It's pointing us toward an entirely new chapter in the story of the universe. We're no longer bound by the rigid timeline of cosmic events we once thought we understood. The implications stretch far beyond a single galaxy. If time can reverse in one place, could it happen elsewhere? Could there be other corners of the universe hidden from our view, where time behaves in ways we've never imagined? Could we one day harness this knowledge to travel through time, or even peek into the deepest, most chaotic moments of the universe's birth? This discovery pushes the boundaries of possibility, inviting us to reconsider everything we thought we knew about the fundamental forces that govern our existence. Imagine what this means for our search for knowledge. If we can understand how time behaves in these extreme environments, we could unlock new insights into black holes, the Big Bang, and the ultimate fate of the universe. This discovery could be the key to understanding some of the most profound questions that have haunted scientists for centuries. What happens inside black holes? What is the true nature of time? Can we peer back to the very first moments of the universe, before stars were born, when the cosmos was nothing more than a seething cauldron of energy and particles? The answers to these questions could forever alter our understanding of the universe. This isn't just a discovery for scientists. It's a discovery for humanity. It challenges us to think bigger, to reach further, and to question the very fabric of reality itself. The implications of this breakthrough could span across fields from physics to philosophy, from space exploration to the very nature of existence. Time reversal inside a dying galaxy forces us to confront the possibility that the universe is far more mysterious and complex than we could ever have imagined. This is the moment where everything changes. This discovery isn't just a puzzle piece. It's a new lens through which we can view the cosmos. It's a call to explore deeper, to question harder, and to dream bigger. Because if time can reverse in a galaxy at the end of its life, then who knows what other cosmic secrets are waiting to be uncovered, just beyond the horizon of our understanding. As we reflect on this groundbreaking discovery of time reversal, within a dying galaxy, one thing becomes abundantly clear. We are standing on the precipice of a new era in our understanding of the universe. What we once believed to be immutable laws of physics, such as the forward march of time, are now being called into question by this extraordinary event. It's not just a fascinating anomaly, it's a pivotal moment that reshapes our conception of reality, suggesting that time is not as fixed as we once thought. Time, under extreme conditions, can bend, twist, and even reverse. This discovery deepens our understanding of how black holes and other massive cosmic objects warp space-time. It opens up a universe of possibilities, prompting us to ask, could time reversal happen elsewhere in the cosmos? Could it be possible to study the birth of the universe, or even peer into its eventual death, in ways we never imagined? The implications stretch far beyond the confines of this particular galaxy, challenging our most fundamental theories about the very nature of existence. But the question we must ask ourselves now is, what does this mean for humanity? If time is more malleable than we once believed, could this discovery eventually lead to breakthroughs in time travel, or allow us to unlock the mysteries of black holes? Could it bring us closer to understanding the origins of the universe, or perhaps even offer new insights into the future of cosmic exploration? The answers are still elusive, but the potential for discovery is limitless. As we continue to push the boundaries of space exploration and delve into the unknown, one thing is certain: the universe is full of surprises, waiting to be uncovered. This discovery may just be the first of many that challenges everything we thought we knew. So, the big question remains: what's next? Will we uncover more cosmic secrets hidden in the farthest reaches of space or within the very fabric of time itself? Only time, however it chooses to flow, will tell. And there you have it. Time itself might be more malleable than we ever imagined, thanks to this mind-bending discovery in a dying galaxy. But this is only the beginning. The universe is full of mysteries, and we're just scratching the surface. If you're as excited as I am about the potential for more groundbreaking revelations, don't forget to like, comment, and subscribe for more thrilling space discoveries. What do you think this means for the future of space exploration? Could time travel become a reality? Or perhaps there are even greater cosmic mysteries waiting to be uncovered? Share your thoughts and theories in the comments below. I'd love to hear what you think. And remember, the universe is vast, and there's so much more to explore. So stay tuned, because the next discovery could be just around the corner. Until next time, keep your eyes on the stars and keep questioning the universe's secrets. Who knows what we'll uncover next?